Hello students. If I'm playing this video for you right now in class, it means that I'm going to be your math teacher for this year, right? So welcome to my class. Since it's the first lesson of the year, it should be right. Usually, this is the kind of video I play on the first lesson. Then it is appropriate that we start with some introductions as well as to really understand, right, what mathematics is really all about since this is a math class. So let's begin with introduction. My name is Mr. Raymond Cheng, right? Raymond is a common name. Cheng, that's my family name. Sometimes mispronounced by some students. Not that difficult. The surname Ng is quite common in Singapore, so you just add a C sound in front. That'll be fine, right? So there's Mr. Raymond Cheng. Hi, right? So the first thing that I would like you to take note is actually my email address. Okay, so that will be actually the main mode of communication outside the classroom, right? So if you need to contact me, for any reason at all, right? So please take note of my email address up there. Few things to take note. My email address does not have my name Raymond there. So it is actually my full name, Cheng Sun Xian. So take note. You may actually take some time to write it down if you are in my math class. Of course, if you're not my math class and you stumble onto this video, you don't really need to have that, right? So take note of that, and let's move on. So let's begin by understanding some of the things you need to prepare before each math session, right? And I'd like to begin by saying that you should have a notebook with you. It could be any kind of notebook. Some people like the large jotter book, some people just a small one. There may be some of you who take notes with your tablet. I'm not going to restrict that. Tablet is fine, but not phones, right? We are talking about writing. Okay, so writing is pretty important in mathematics, despite us being in a technology school. Yes, we use a lot of devices, but the art of taking notes with a pen is actually pretty important. But other than note taking, take note that what I've written up there on my slide is actually note making, right? There is a difference between taking notes and making notes. I'm not going to go into detail in this introduction video, but notes will be provided for you, right? So to actually be more efficient in our lesson, I don't really need you to take notes. But making notes is a little extra effort that a good student will do as they listen to the lesson, engage in the lesson, and from the notes that they have, they synergize the information and create meaning out of the words and diagrams that's on their notes. So it is way more than just note taking. And for those who are interested, I like to implore you, make some effort, do a bit of research between the difference between note making and note taking, and hopefully you master the skills of note making as soon as possible, and that will definitely help you in the learning process. Well, for most of the lesson, there will be handouts, right? So I'll pre-prepare some notes for you that you can follow along in the lesson. So please bring them to the class. Now you need to have calculators. You should know that there's a proof of calculators for use in our assessment as well, examination and test. You should have them every lesson. I mean, we use technology over here. I know some of you may be well trained in the art of mental calculations. We don't really need that skill in this syllabus. Of course, it is not saying that if you train yourself to be good in mental calculations, it's a bad thing. It's a good thing, but have calculators. All right. Now, finally, I'd like to actually request that you prepare a ring file, orange in color. That's the color that we standardize over here. When we are done with the lessons, the notes, the handout, it should go into the ring file. When we have class tests and your exam papers should go into the ring file. Let's also cultivate the habit of actually keeping our things well archived, our handout, our notes, put them together in a nice file as a record of your learning. I think this is a good habit to start. You will find that keeping things, learning how to organize, right? It is not just about keeping all the things because we don't want to throw them away. Some of you may use them for revision, some of you may not, but it is about learning how to organize ourselves and keeping ourselves organized. So it's actually a life skill as well. So pick up the habit early, prepare a orange files where I would like you to organize all the documents regarding mathematics to go inside this ring file. All right, let's move on. Right, so of course, before the lesson start, I'd like to set out some mindset, coming into the maths lesson. There will be a significant difference between the mathematics that you have learned in primary school compared to secondary school, right? So the first thing I'd like to mention is that sometimes we will fail, right? I know some of you may not have experienced failure yet in your life. You're still relatively young, but do not fear failing, because when we try to learn more and more advanced mathematics, everyone will reach a stage where you do fail. There's nothing wrong with failing. Do not fear failing. However, it doesn't mean that we accept failing, right? So when we fail, of course, we try to reflect upon it and see how we can actually progress from there. So there's nothing wrong with failing, and there's nothing wrong with not knowing, because there are so much knowledge out there. It's impossible to know everything, right? So if you don't know something, it's fine. We learn to look it up when we need the information. But there is everything wrong with not trying. So I can accept that you did not learn something, you don't know something, but if you're not trying, that is a attitude that it is not wanted in this class. So we got to try, even whether we understood the lesson, we don't understand, or whether we don't understand the lesson, we give it a try. And it is the trying, the effort, that allow us to progress and improve in the subject. And of course, when it comes to assessment, be prepared, right? So when we talk about prepared, it is only right that we try, we prepare, and we come in and give it our best shot. That is the only way to progress. Because if you give up too easily, don't prepare, then a lot of wastage in terms of the efforts that the teachers are trying to reach to you, your support system of your friends, your parents, you're letting everybody down. I know it sounds like I'm giving a lot of pressure, but it is part and parcel of being a good student. Okay, so make sure you try, make sure you prepare, right? Even if you don't understand, it's fine. The support system is there to help you to learn, but you try. Okay, always try. Right, so some other details here on what it means to have a mathematical mindset, right? So the first point over there, I've written down: mistakes are really valuable. It is through mistakes that we learn, right? So I'm sure when you are in primary school, sometimes when you make a mistake in mathematics, your teachers will encourage you to do corrections. That is a vital point, because for most of us, it is actually corrections that allow us to learn the most. If we score full marks every time, sometimes we got the correct solution without fully understanding the concept, right? But when we make a mistake, we make the effort to reflect upon the mistake, and that's where deep learning actually happens. So mistakes are valuable when we do corrections. Ideas or questions are really important. Sometimes we think that getting the right answer is what's valuable. Not necessary. Coming up with the right questions to ask, that is where true learning actually takes place. So we will find that we will ask ourselves a lot of questions as we go along this journey. Now, the next point, it is not about the correct answers, but about understanding. I think I've mentioned that. Of course, we want the correct answers, but not knowing the correct answers is not the worst thing. Okay, when we make mistake, we try, because we try and we try to prepare, we gain understanding, and that's why that's more important. Okay. Next point, depth over speed is what makes you good at mathematics, right? So there's no need to be fast. Sometimes we get the wrong idea, especially when we are younger and we are just learning the very basics of mathematical operation. We thought when we can add things up, subtract or multiply things very quickly, mentally, mental sums, we thought that means you're good in math. Not necessary. Okay, it just means that you're fast in mathematics. But being fast is not the most important skills that you should have, but rather the depth of understanding, right? So I like to make that declaration right here. Sense making and creativity are what math is about. Okay, so it is really about trying to look at our world and try to make sense about it, try to understand it and put it in a structure mathematically so that we can organize and interact with our environment. It is really that is true mathematics. So everybody can learn mathematics at the highest level. So you may be thinking, I've not done well for math for a long time. Are you sure I can learn at the highest level? Oh, definitely, right? It is not, you see, mathematics as a discipline, there are many approaches to it. We may not be able to reach the higher level on a certain pathway, but every mathematical concept has a multitude of ways to reach the understanding, and different students actually requires different examples to actually trigger their understanding. But it is up to us to seek out what works for us, right? And that is again what a good student is all about, and note making is all about. You create a structure that helps you to understand the concept, right? So what the teacher does, okay, what I will do when I give you your notes is to give you the overview, fundamentals, and then to internalize the knowledge. It is up to you to make the notes, form the connections so that you understand the concept. So you need to play a part, right? And of course, talking about mathematics and connecting mathematical ideas help us to learn. So you will find that over here in this school, in my class, there will be opportunities where you'll be required to present your understanding. I won't do most of the talking. Today I will, because today's introduction. So I'm speaking to a camera right now. Going forward, as we learn new mathematical concept, I will want you to actually repeat back and then to explain to your fellow classmates what you have learned. So be prepared for that, all right? Right, so the next thing we're going to do, okay, is that we want to understand exactly what is mathematics. So if you'd like to answer this question, if you're watching this on my, on not in class, but on your own in a video, feel free to pause and try to answer it in the comment section. Right, but if you are in class right now, well, I could pause the video and can talk about it. All right, unpause. Right, so here's the interesting thing about mathematics, right? So sometimes the word mathematics is quite difficult to define, right? So when we talk about other disciplines and other subjects, sometimes it's quite obvious, right? So if you are studying, let's say, the science of physics, it means to study the physical law and the physical world, right? If you are studying chemistry, you'll be studying about the chemical component and chemical reality of the materials that we come into contact with. And of course, things like history will be studying case studies, things that happened in the past, and what we can learn from them, and so on, right? But mathematics is quite difficult to define. So some people may think mathematics numbers, because that seems to be the first mathematical object that young children is exposed to, or maybe shapes. But then as we progress and we sometimes look at videos and even comic strip or whatever media you have of high level mathematics, is so confusing, right? So what exactly is mathematics? Here's the a definition in words, wall of text. Let me just read it out for you. Mathematics can be described as a study of the property, relationships, operations, algorithm, and applications of numbers and spaces at the very basic levels. and of abstract objects and concepts at a more advanced level. Mathematical objects and concepts and related knowledge and methods are products of insight, logical reasoning, and creative thinking, and are often inspired by problems that seek solutions. Abstractions are what makes mathematics a powerful tool for solving problems. Mathematics provides within itself a language representing and communicating the ideas and results of the discipline. Okay, at this point of time, I don't actually expect every one of you to understand what that paragraph of words actually means. It will take some time, but just want to pull out a few pointers for you, right? So mathematics, first of all, is not just about numbers, it's about the applications of numbers and space. So we use it to apply and find solutions, right? There's problem solving, okay? There's abstraction, and interestingly, it is also a language, right? So what is actually a language? A language, as we know, is a tool for which we communicate. So different languages is learned by different cultures, but what about mathematics, right? What are we communicating? At its core, mathematics actually allow us to communicate ideas, right? And ideas, depending on the nature and the type of ideas, we need different mathematical object to represent ideas. So sometimes we use numbers to represent the idea of quantity, and we use shapes to represent the idea of a certain reality and geographical items in this world, right? So since it is a tool for communication, which is also one of the things I would like to highlight. Sometimes you will hear mathematics teachers tell you that you should always show your working when you actually write mathematics. Of course, there's this problem-solving aspect of mathematics, which is to get the answer to a problem. Very often we will do that, right? Especially in the examination, sometimes when we're new to it, we just want to get to the answer fast. However, as we learn more and more higher advanced mathematics, it is not the solution that is most important. It is about communicating the idea. And that is why a good habit of really presenting our solutions in a logical, systematic, algorithmic way actually goes a long way in communicating ideas. So, starting from secondary school, right, in contrast to primary school, this point about showing your working becomes very, very important. And as we go through each of the topics that we will be doing for the syllabus, I will emphasize this point again and again. And I hope you cooperate, do your best, never skip the working, because we are communicating ideas over here, not just trying to get the answer. All right. Right, so to sum it up, okay, just now the whole paragraph, I know paragraph can be quite scary. This little diagram over here allows us to have a little bit of clarity of what mathematics really is all about. Okay, it's a study of mathematical objects, but mathematical objects can be used in a variety of ways. It can be used to actually talk about properties and relationships. It can be used as a representation and communication, right? Communication of ideas, we mentioned that. And also on operation and algorithm, these are things that we learn very early about operating on the objects. Like a number is a mathematical object. We do operations on it, addition, subtraction, for example. And abstraction and application, right? Using it to solve real world problems, right? Or your problem sums, right? So that is actually abstraction and applications over here. And of course, just now we mentioned that mathematics, one of the key components in secondary school is the communication of ideas. So when we talk about ideas, what kind of ideas we are really talking about? So to distill, there are many ideas, but in your syllabus, right, in our syllabus, these are the 8 big ideas that have been identified. So through the course of this syllabus, you will be getting more familiar with them. But of course, you have these words in front of you on your screen. If you want to find out what they mean, feel free to make use of, right, the technology. Go to the internet, do a bit of research so that you understand the meaning of each of these words. Their functions, models, invariants, equivalence, notation, proportionality, diagram, and measures. They're pretty important. You'll be getting familiar with this, all right? Now, so what are we trying to understand, right? By going through this entire mathematics syllabus. So there are some points to mention over here. So you can see the subheading here, enduring understanding means understanding that persists and lasts. Important thing that we need to know about mathematics after we go through the curriculum and the syllabus, right? That mathematical problem solvers apply a variety of strategies and methods to solve a problem. So that's the first thing, right? When we encounter a problem, how do we actually use mathematics concept to actually solve them? Connections, right, are made within different areas of this mathematics and between other content discipline. Mathematics also connect to the real world application. So there are many things in our real world that requires us to use mathematics so that we can understand it better, right? To create a model so that we can do calculation, do some prediction, do some understanding of how the world works. That is connection. Mathematical reasoning is evident by testing and evaluating statement and justifying steps in mathematical process. So that one comes down to our communication of ideas. When we communicate ideas, it has to be reasonable, right? So we need to be able to reason out why a certain property leads to other properties, leads to the next property, leads to the conclusion, for example. And the language of mathematics is communicated through specialized vocabulary and symbols used to represent and describe mathematical ideas, generalization, and relationships. So you know mathematics has lots of symbols that we use. All these symbols, they have very specific meaning. So we need to learn them so that we can communicate the ideas accurately, right? So we cannot just use the addition sign and say, let's change this to mean a division sign. It doesn't work that way. There is a standardization that we need to know and need to have. Okay, so representing mathematical ideas involve using a variety of representations such as graph. So we learn how to use graph to represent the ideas. Numbers, we use numbers. We use algebra. Okay, so we will talk about algebra in soon, right? We can use words, of course, which is why problem sums are part of mathematics syllabus. And physical model, right? We can see 3D objects, 2D objects to convey practical situation. So these are all the things we deal with. What are their relationships, right? Okay, so to sum it up, okay, there are actually two directions, two pillars, I would say, or when it comes to learning mathematics. So learning mathematics as a tool, it is a tool that we can use, right? Learning and applying the concept and the skills to solve problems, including those in context. So that is the first pillar of mathematics. The second pillar of mathematics is learning mathematics as a discipline, right? It is to develop process, right? Understanding the processes, the communication, the meta-cognitive skills, right? The reasoning skills through a mathematical approach to problem solving. So these are the two pillars. So sometimes some students struggle with mathematics. Earlier I mentioned that everyone can learn mathematics at a higher level. Which type of students fail to do so? When they fail to look at mathematics from both of these pillars. When you only have one pillar, the whole concept topples. So I want you to have this awareness that we are using mathematics as a tool, as well as as a discipline, right? Right. Coming to this very popular, I would say, model for problem solving, because problem solving at its core is a very huge component of the mathematics, and we have this Poyer's problem solving model. So this document is easily available. You can actually look at this diagram, but generally the thought process that we have when we encounter a mathematics problem is to first understand the problem, right? So how to understand the problems? Earlier I also mentioned that the ability to ask the correct questions is actually a more important skill than getting the solution, right? So we ask questions to fully understand the problem. And when we understand it, then we look at our toolkit, right? We use mathematics as a tool, right, to devise a plan, trying to figure out which tool to use. After that, we carry out the plan by organizing things, right? That is where we use mathematics as a discipline, okay, organize everything in a very algorithmic manner, logical manner, right? Very reasonable manner. And then after that, if we apply that, we should get some kind of results. Then we look back, check back, see if our result is actually reasonable. So this is the entire process known as the Poyer's problem-solving model, right? So I hope you can actually learn about that. Right, finally, let's talk about reflection. Oops, let's take this away. Right, sometimes when we make mistake, earlier I talked about making mistakes. Sometimes when we make mistakes, let me just plug in the charger just in case, right? Okay, right. When we make mistakes, we want to learn from our mistakes. Mathematical mindset, yes. So sometimes we say mistakes, everything is a mistake. But in order to make the mistake more valuable, right, we need to actually understand that there are different types of mistakes. Okay, so in mathematics, there are generally four main categories. You have the factual mistakes, conceptual mistakes, procedural mistakes, computational mistakes. So feel free to pause the video to read in details some of the questions we ask ourselves. Remember, asking ourselves questions to figure out each time when we make a mistakes, which type of errors are they? And when we can identify the type of error, that's where we know how to actually apply the correct corrections, and that's where true mathematics learning takes place. All right? And we should be able to communicate mathematics. So other than just using the toolkit and answering questions, finding solution, one important thing about mathematics is to be able to communicate the ideas. So you will find that in your syllabus, there will be sections, okay, a part of it that requires us to explain the mathematics, which is why I mentioned earlier, I'll give you opportunity to do that. So when we explain, there are, again, okay, different type of explaining. As you can see, they are explaining why we make certain decision. Based on our mathematical model, we explain why we make certain decision given the scenario. So we explain whether it is this or that, explain which one is greater or lesser or faster or slower, etc. Right? We also like to explain through inference. Explain what it means, right? If I get this result, what does it mean? What does it imply? Okay. There are also a type of justification called validation, which will explain why certain error is like this, why someone make this kind of error when they are actually working on the mathematical solution, for example. And finally, on elaboration, right? Sometimes we want to explain how, okay, give the strategy, the algorithm to actually obtain the result that we want. So once again, just take a quick read. You may pause to read in detail. We will actually use all these tools in our syllabus. All right. So finally, something that I'm sure you're very concerned about, how would you be assessed in your mathematics? We have examination, test, quiz, participation in class, and projects. So there are lots of different ways we can be assessed on our understanding. But generally, there are three levels. Okay, so over here, when we assess, there are certain objectives, okay, that we want to hit to know whether we understand the mathematical concept. So the first level we call AO1, assessment objective 1, is the use and the application of standard techniques. So you learn certain techniques to actually solve and demonstrate mathematical concept, right? So these include things like recall and use facts and so on, right? Routine mathematical procedure, very standard procedure, just follow the procedure, get the solution. So very basic level. At the next level, we will have AO2, assessment objective 2. This is to solve problems in a variety of contexts. So there will be certain scenario that may be presented, and you need to actually, ask the right question, right? The first step of Poyer's, ask the right question, figure out what you need to do, extract the situation, and then, formulate problems into mathematical terms. That's abstraction, right? Then we analyze, select the information we need, and then we use the mathematical technique to solve it. Finally, to interpret the results in the context of the given problem, right? So since it has a context, we always need to go back to the context. Looking back, that's the fourth step of Poyer's problem solving algorithm, right? And finally, we have AO3 to reason and communicate mathematically. So the ability to communicate mathematics is important. You need to provide explanation in the context, right? Be able to explain. Just now, I show you the earlier framework. You can look at it again. And of course, to write mathematical argument. So you need to be able to write down your reasons properly, and also to write down and show and communicate your ideas properly in full working. So these are things and skills that you need to actually pick up through the mathematics course over here. Okay, so I hope you have a better awareness of what we are going to do, right, in my mathematics class, and wishing you a good year ahead. Wishing me a good year ahead, right? We help each other over here. Okay, so I of course I can't expect you to remember everything that I've said in this particular video. I will actually provide the link to this video where you can actually watch it again and try to digest it. And maybe few months later, when you have gone through quite a bit of the syllabus and the curriculum, you may come back and watch this video again, and you will actually have a better understanding of what we are trying to do over here. All right. So with this, this end the introduction, and I'm not sure how much time we have left in the classroom, because I plan to play this video for you in the classroom. But the remaining time, we can have a AMA session, right? So that's it for this video for now. Have a nice day.